Good afternoon, everyone, and welcome to Protecting Your Internal Diamond Pipeline, presented by the Davies Institute of Diamonds. My name is Carly, and I'll be your moderator for the presentation. Today's webinar will meticulously unfold the intricacies of the laboratory-grown diamond detection process, offering a comprehensive understanding of each crucial stage. Just as a general note to our attendees, all of your mics are muted. That said, if you have any questions for our presenters, feel free to post them in the Q&A forum, and we will address them at the end of the presentation. If you have any technical questions as we get started, you can use the chat feature to communicate with us, and we'll do our best to help you out. Today's slide presentation and our speaker's audio is being recorded, so we can provide you with the material afterward. Now, I would like to introduce our speakers, Dr. Nick Davies and Samantha Sibley. Nick is a project lead in research at Davies Group Ignite and Maidenhead, UK. He currently leads one of the diamond research projects within Ignite, and during his 20 years at Davies, he has played a key role in the development of technology critical to maintaining consumer confidence in natural diamonds. Nick is also a member of the team responsible for promoting consumer confidence as part of the wider group strategy through the delivery of professional education. Samantha has more than 30 years' experience in Davies research and development teams and brings a wealth of knowledge regarding the characteristics of both natural and laboratory-grown diamonds. This research has resulted in several publications in both gemological and scientific journals. She has been involved in the development of Davies' current and previous suites of diamond verification instruments and currently also facilitates training and education courses globally on the use of these instruments to obtain accurate screening results. An important part of Samantha's role is interaction with the client and feeding back any information that can enrich further developments in this area. And with that, Nick and Samantha, please take it away.
Thank you very much for the introductions. We would like to start by thanking you for the opportunity to discuss the research, development and the education work that is undertaken by the Davies Group. So myself and Nick will hopefully uncover a few of the areas that we are working on. The presentation will last for around about 40 minutes, I think, which is going to leave a lot of time at the end for lots of questions. So hopefully we will answer some of your questions during the presentation, but if there's any others, as Carly has mentioned, please enter any in the chat or wait till the end and we can cover off some of those. So the idea behind today's presentation is really to cover a few of the things. So the overview, which we are going to cover here, is a little introduction on who we are, the work that we are currently involved in and why we do it. You know, why is Davies involved? We will, I will do mainly some of the introduction at the beginning, and then Nick will go into a bit more detail on our consumer confidence technical research program. So that's more about the research, more about benchmark studies on natural diamond. Obviously, we have access to natural diamonds from our own mines. And then also the research that we do into both synthetic diamonds and also diamond treatments. I will cover a little bit on definitions. Obviously, it's very important that when we're talking about simulants, synthetic diamonds, treatments, we know exactly what we mean by that and that we're using the right terminology. So I'll just go over some of that work. And then towards the end of the presentation, we'll go into a bit more detail on the development of some of our diamond verification instruments, the ones that have been developed, researched, designed and developed within Davies. And then some examples of the screening methodology and some case studies where we might use the instruments, whether that's for loose or for jewelry pieces. And then we'll have a bit of a summary at the end and then the questions. But I think it's important that we start off with Davies and who Davies is and why it's important, the work that we're doing. So since 1888, well over a century now, Davies has been involved in the diamond industry with the source of many diamonds journey from the initial discovery of the diamonds from the rough all the way through to the production, the sales of the rough, the manufacture, and then also the sales of the beautiful jewelry pieces that we all know and love. So it's all about that story of discovering that natural gem and the magical transformation of that rare treasure. So when we're talking about diamonds, and then we're comparing to synthetic material, diamond simulants, diamond imitations, which a lot of those are man-made as well. They're just such different products, and I think it's really important that we remember where those diamonds have come from. We know it's one of the world's most precious treasures because they were created in the earth billions of years ago. So we know that some diamonds are as old as 3.5 billion years old. So that's almost 3/4 of the age of the earth. So it's incredible that we actually get to see, feel, and wear something that's old. They've all had their own unique and incredible journey, and that's what makes each diamond so unique. So if we look at where we are placed within the De Beers group, so who we are, so myself and Nick and the IOD. So myself and Nick work for Ignite, which is part of the research and development, the technology side of De Beers. And then the work that we're involved in covers a lot of the diamond pipeline. So you can see in the top right-hand side of the slide here, where De Beers features within the diamond pipeline. And we're all the way back from exploration and discovery of those natural wonders all the way through to the sale of jewelry pieces and magnificent jewelry pieces there. You can see that Ignite and De Beers Institute of Diamonds sit right in the middle of that pipeline, which is an advantage for us because we get to see all aspects of the pipeline. So we can collaborate and work with the exploration team and that side of things, and the sales side all the way through to retail, and have that access to that knowledge, that understanding, which helps within the research, but then also in the education and the training and those services that we can get out to the trade as well. So from a research point of view, it's the fundamental research on diamonds, like I said, our benchmark studies looking at known natural diamonds, but then using that research to develop instrumentation, manufacture those instruments all in-house. We do that all within the Maidenhead facility here in the UK as well, and then also be involved on the commercial sales side of things. So we're there to offer advice on what sorts of instruments work, what sort of process might work for your environment, and hold your hand almost through that process. So that's where we fit, the Ignite IOD, within the De Beers group. So what exactly do we do, and why do we do it? Why is it important to De Beers? So you can see that on the right-hand side there, we talk about our 3D strategy. So Nick will go into more detail about the consumer confidence technical research, but our 3D strategy has been core to our business in the research and development area for many, many years. And what we mean by that is the 3Ds are detection, disclosure, and differentiation. So we know that disclosure is critical to the industry. It's so important that a consumer knows exactly what they are purchasing, and the right nomenclature, terminology is used when describing each of those different offerings. Differentiation and disclosure go hand in hand. And because detection is possible, we can detect all synthetic diamonds, and we'll go into that in more detail. It really encourages full disclosure within the trade. We always know that there are cases where things aren't fully disclosed, but if we can try and encourage that, and we owe that to the consumers to get that terminology and that disclosure correct. So when we talk about definitions and terminology, I've just got a slide here on simulants, synthetic diamond, and treatment. So what do we mean exactly when we're talking about simulants? So if we talk about a diamond simulant, it's a diamond imitation. So it's a lookalike. And most simulants that are used in the industry today are man-made. So examples, cubic zirconia and synthetic moissanite. So they look like diamond, but they're a completely different material. So they have different chemical composition, they have different physical properties, optical properties. And what that means is they're a lot easier to detect and be able to distinguish those. There will be physical features, visible features that you can use to differentiate the simulants of diamond imitations from a natural diamond. When we get to synthetic diamond, it is diamond material. So it's going to have the same chemical and physical properties. So they may look very similar. But what we're looking at they look very similar, but they are different. And Nick will go through more detail on how we can distinguish those. But it's essentially because they grow in a very, very different environment. If you think of natural diamonds deep in the earth, very high temperatures, pressures, over very, very long time periods and a long, long time ago, whereas synthetic diamond is a very different environment. And Nick will touch on that. And when we describe a synthetic diamond or a man-made diamond, there are 3 accepted terms. Synthetic diamond, laboratory grown diamond, or LGD, you might see abbreviated, and then laboratory created diamond. And then on the treatment side of things, we're not talking too much about treatments today, but just to touch on the fact that you can take a diamond and treat it in some way to either affect the color or the clarity of that material. And we know that there are many CVD grown synthetic diamonds in the trade that subsequent to the growth of the material, they've then been heat treated to remove the brownish color to make them more colorless. So when we're looking at an unknown sample, so when samples come into our IOD De Beers laboratories, what we need to look at is not only is that sample natural, but we have to make sure that that's untreated as well. So we're the only laboratory that will only grade natural untreated diamonds. If a sample has been treated or is synthetic in any way, then that's just returned to the customer. So I think that gives you a good overview of where we're coming from. So looking at the research and the development in general, we're positioned in a very key place within the De Beers group, that we've got access to all the knowledge of the sort of recovery side of things, what natural diamonds look like, getting hold of natural diamond material so that we can do our research on that, but then also working with other parts of the business, such as Element 6, to look at the synthesis. And again, Nick will go through that in a bit of detail. So I'll pass you over to Nick for the next few slides.
Okay, thank you, Sam. Okay, thanks. So let's look at the detection of synthetic diamonds. So in the next few slides, what I'd like to do is talk you through fundamental differences between natural diamond and synthetic diamond, and then talk a little bit more about De Beers' approach to consumer confidence technical research that Sam has mentioned. So the differences between natural diamond born within the earth and synthetic diamond that's manufactured within a lab or a factory, those differences are very difficult to identify, if not impossible, with the loop and tweezers, especially when the stones have been polished up. Identification prior to polishing is much more straightforward. The natural rough diamonds have a very different morphology to the as-grown synthetic diamond. But obviously, once you polish those diamonds up, those clues, those key clues will disappear. So once polished, we need to look at some more sophisticated techniques rather than the loop and tweezers. And luckily, we have those more sophisticated techniques in Maidenhead. So one of the more sophisticated techniques, probably a unique technique that we use in the lab, is some X-ray analysis. So you've probably heard in the media that people say you can't tell the difference. And potentially with the loop and tweezers, they are very difficult to identify. But with X-ray technology and technology that we have in the lab, you can tell the difference. So if we have a look at a natural diamond, so this natural diamond, so this is an X-ray image of a natural diamond. This is actually a rough natural diamond that we're looking at. We've taken a slice through that. You can see that the growth starts in the middle and then radiates outwards, very much like a tree ring structure. If we compare that to a synthetic diamond, so this is a synthetic diamond that has been grown using the chemical vapor deposition technique, and I'll talk to you about that in the next few slides. But you can see it's a much different growth structure. It's a very linear growth structure. And these differences come about because the environment and the growth conditions that these two different diamonds grow in are very different. So in terms of the statement, you can't tell the difference, you can, you just need the right technology to do that. Okay, so the fundamental differences between natural diamond and synthetic diamond are a result of the different growth environments and conditions. So natural diamonds growing hundreds of kilometers below the ground under extreme temperature and pressure. And synthetic diamonds obviously grown above ground. And there are two main methods of production. We have high pressure, high temperature, so HPHT production. So you can see the presses that are used to grow the diamonds. And here you've got what the as-grown product looks like. So HPHT, as the name suggests, high pressure, high temperature, it does try to mimic some of the conditions that you find within the contrasting technique, so chemical vapor deposition, another production method. So this is very different from the conditions that you'd find within the Earth, much lower pressure. And what you find is that your as-grown material looks a bit like this, not very exciting. And what you find is the CVD process is probably the more popular process of producing synthetic diamonds. It's a little bit more accessible. That technology is more accessible than, say, a HPHT press. Okay, so how does De Beers consumer confidence technical research help you identify synthetic diamonds in your pipeline or in your process? So on the left-hand side, we've got our philosophy to this research is really look at future detection challenges. And we use a variety of lab-based techniques. So you saw some X-ray techniques that we use. We've got access to natural diamond benchmarks, and we work with Element 6. So Element 6 are part of the De Beers group, and they specialize in developing a synthesis process to produce synthetic diamond products. So we work with them. We have this sort of constant innovation cycle where we develop a detection method, we then test that with synthetic diamonds that Element 6 is grown for us, and we go around that loop trying to make sure that our instruments that we develop are fit for purpose now and robust into the future. We try and develop a deep understanding of diamond. And what we try and do is we try to work in that region where, so this region in the middle is kind of perfect storm region. So this is the region where something might be a process of growing diamond, might be commercially viable, it might be technically possible, and it might be difficult to detect. So we try and make sure that we operate in that area. Okay, so how do these two things benefit the industry and consumer confidence? So through detection, as Sam said, one of the key pillars of our 3D strategy is detection. You can't have disclosure and differentiation without the means of detection. So that's what we provide. So all that research that we do, we try and package that into an instrument that is easy to use, so you don't have to X-ray your diamonds. So in the next 3 slides, I just want to take you through a very whistle-stop tour of a development of an instrument from research into actual production. So you may be familiar with the Diamond View instrument. So this is really looking at the Diamond View instrument, and Sam will talk about the performance of that instrument later. So if we look at the left-hand side, what we're doing, we're actually imaging the growth structure of the diamond crystal, and we're using a fancy technique called cathodoluminescence. What we found through research is that the growth structure can also be visualized using shortwave ultraviolet light. So on the right-hand side, we have a fluorescence image that has been generated by illuminating the stone with shortwave ultraviolet. So this reveals the growth structure in a similar way to the more complex lab technique. So if we take a look at this slide, so this is examples of 3 different types of diamond observed using Diamond View. So if we look at the natural diamond, so here we know natural diamond grows between 100 and 200 kilometers below the Earth at extreme temperatures and pressures. And what we see, if we were to look at that with Diamond View under shortwave ultraviolet, we'd see a nice blue color and this random network structure, very characteristic of natural growth. If we were to take a look at HPHT synthetics, what we'd first of all see is it's turquoise, so we don't have that blue color. But what we can also see is this blocky structure here. And that's symmetrical and very uniform, you know, like a result of a man-made, mass-produced product. So from this, we can identify that we've got a HPHT-produced synthetic diamond. And then finally, if we take a look at a CVD synthetic diamond. Immediately we can see it's orange, and we also have a striated structure. And that striated structure tells us how the diamond was grown and tells us that it's a CVD synthetic diamond. Okay, so that gives you hopefully an overview of the consumer confidence technical research and how that fits into actually producing instruments that you can use in your labs, your offices, etc., to identify natural and synthetic diamond. So we have a range. Diamond View isn't the only instrument that we produce, but we do have a range of diamond verification instruments, and Sam's going to talk to you about those shortly. Thank you.
Okay, thank you, Nick. Okay, let's talk about the instrument. So what's really important when you're looking at diamond verification instruments is whether you are screening your instruments or whether you are really looking for an instrument that's going to detect and give you a definitive answer. So where we look at screening and detection, there's over the last maybe 5 to 10 years, there's been lots more verification instruments developed and sold in the industry as detection instruments, and they're not necessarily detection instruments, so they will not detect what you were looking for. So they might screen, but they won't give you a final answer. So what we understand as screening instruments or screening devices is that it's an examination of maybe a larger parcel. You would put many stones through a device. The vast majority would pass as natural diamonds if they were natural diamonds, but that you may get a small percentage that would refer for further testing or need additional testing alongside all of your synthetics and all of your simulants. So a good screening device will obviously not pass any synthetic stones, and it will not pass any simulants. It will only pass natural samples. But you may have some natural diamond samples that need this further testing because they're a particular type that could potentially be synthetic or treated in some way. So that's what we understand as a screening device. And then a detection instrument, so something like our Diamond View instrument, which Nick's shown you a few images already, is where you actually get an image. In this case, you get an image on a screen, and the user can actually interpret that image and make a call on whether it's a natural diamond or whether it's man-made in some way. And actually with the Diamond View instrument, you can actually deduce whether it's HPHT or CVD grown as well. So that's important to know. And I can't iterate this enough. It's really important to know what your diamond verification instrument can do, but also what it can't do. So important to understand the technology that's being used, what it's measuring, and then how that might fit into a process flow, which we'll go into in more detail. So the next few slides just go through some of our instruments, essentially. So just to give you an idea of some of the technology that's out there. So the first one is the Diamond Shore instrument. So the Diamond Shore is, can I have the next slide, Nick, if possible? So the Diamond Shore instrument has been around for many years in various iterations. So this is the third generation of Diamond Shore instrument, and this is what we've always called our front-end rapid screening instrument. So it's take a diamond, place it on the Diamond Shore. So the top right-hand image there, you can see on the sample dish, you would just place your loose stone, table down. We can look at some simple jewelry settings. The probe can actually be extended from the instrument as well to do some simple testing. But it's a case of putting the stone down, pressing the test button, and within 4 seconds you get a result. So if it's a natural diamond, we get a pass result. So it's very quick, it's very easy to use, but what it's doing in the background is something quite technical. So what we're trying to do is differentiate diamond from diamond, essentially. So it's a natural diamond from a lab-grown diamond. So we're taking a spectrum, a graph, over a range of about 300 to 500 nanometers. The instrument is then looking at that data, and the clever algorithm or program that's built within the instrument then makes a call on whether it's going to pass that diamond or whether it's going to refer it for further tests. So around 98% of colourless to near colourless diamonds will be passed, and around 2% of natural diamonds would be passed on for further testing. They'd be referred for further testing. And they will essentially be your type 2 diamonds, which could be synthetic or treated in some way, and your type 1AB diamonds as well. So particular types of diamond we need to look at it further because they could be synthetic or treated. So that's the diamond sure, and that's really what we use at the front end, and these are used in our laboratories as well for our front end screening. So anything that is then referred for further testing, we would put on a diamond view instrument. So you've already seen some nice images that Nick showed of from the diamond view. So you essentially you load your sample in. So bottom right there, you can see you've got your diamond, again, a loose diamond held there. If we close the sample chamber and switch on the ultraviolet light source, so it uses shortwave ultraviolet, that shines on your diamond, it fluoresces, it glows, it gives off a colour. So first of all, we're looking at that colour. Is it that nice blue colour that we see in the natural diamonds? Have we got that nice vein-like structure? Or is it more like the synthetic stones where we get the turquoises, the oranges, some treated synthetic material shows more of a greenish colour. So they're the warning signs if we see greens and oranges and those sorts of colours. The user then looks at that image and then can make a call, first of all, on the colour, but also on what patterns we're seeing there. So is the pattern that you're seeing indicative of the from the natural diamond, or is it more akin to some of the man-made diamonds that we've shown images of already? So, and as already mentioned, the diamond view can distinguish HPHT from CVD-grown synthetic diamonds as well. So a really nice tool. We use this, a lot of gem labs use this as a research tool as well, because it's nice even if you're trying to understand synthetic growth, you could take cross sections and you can image those. So really nice as a research tool, but really nice out in the industry as well to check loose polished stones as well. So that's the diamond sure and the diamond sure, but they really work hand in hand quite nicely in part of a process, and we'll talk about some of the processes in a moment. The next two instruments, the Synth Detect and the AMS2, are using a slightly different way of analysing fluorescence and phosphorescence. So it's still using ultraviolet light, so it's still shining, illuminating the diamond or the jewellery piece in this case with UV light, and it glows, it gives off an image. But what we're doing in this case is looking at the phosphorescence. So that is the afterglow once the UV source has been switched off. Does it continue to glow? And in the case of what we're looking at with the Synth detectors, we're looking for a particular colour of phosphorescence that we see in a particular time window. So it's essentially about sort of 8 to 10 milliseconds after the UV source has been switched off. So we couldn't physically see that, but the instrument is designed to capture that image and then make a call on whether it's natural or it refers for further testing. So you can see on the right hand side the image, we've got a natural stone and a synthetic, an HPHT synthetic stone there. So the natural stone is showing natural, the HPHT is showing refer, and the built-in algorithm, the software, will automatically give you that response if you just click on each of the diamonds. So it will tell you. The idea behind the Synth Detect is that we can look at jewelry pieces as well. You can still look at loose, but we've got various attachments, various accessories that you can locate in the lower part of the Synth Detect, whether it's rings, bracelets, you can rotate them around. So as you're imaging it, you can rotate the jewelry piece around and essentially look for that nice blue colour that we'd expect to see, for example, in that tennis bracelet in the right-hand side. So it's a nice, easy instrument to use, and you get an instant response as well. So that's the Synth Detect, great for looking at loose and also jewelry. And then the AMS uses very similar technology, but in an automated fashion. So it automatically screens and dispenses your smaller diamonds. So down to, we're talking 20 points down to a third of a point. So the smallest diameter of diamond that AMS2 can screen is 0.9 millimeters. So getting down very, very, very small there. What the instrument does, it automatically, so you pour the samples in, it automatically feeds the samples into the instrument, measures them, and then dispenses them into one of the result bins at the bottom there. So the result bins will either be pass if it's a natural diamond, so nice clear cut case. Refer could include some natural diamonds and some synthetic stones, which we would need to look at in more detail. There's the synthetic bin for 100% sure that that's a synthetic diamond. And then non-diamond is for any imitations or simulants. So cubic zirconia, synthetic moissanite, anything that is essentially not diamond material would end up in the non-diamond bin. And it uses similar technology to synth detect. So what's really great with this is that samples can be, your melee can be screened using an AMS2 type instrument. And then once set in the jewelry pieces can then, using the same technology, be tested again with the synth detect. So really nice that they work, again, they work hand in hand. So that's 4 of the instruments that we have developed in-house. As I mentioned earlier, it's really important to understand your DBI. So important to know what resources are available to help with verification. So not everybody's in the situation that Nick and I are in, where we've got a all singing, all dancing laboratory where we've got every instrument under the sun. So it's important to know that maybe, would an individual instrument help your business? Is it a combination of things? Maybe a diamond shore, diamond view? Is it an AMS synth detect or something else along those lines? Screening processes is really important. So where does that instrument fit into your process as well? And it's, are people involved in dealing with loose and polished and set jewelry? So what's going to work well for you? And if you haven't got the capabilities in-house, then what laboratory services are there on offer? So as the Davies group, we have the Institute of Diamonds laboratory. So we have 3 locations where we will grade natural untreated diamonds, but also offer melee testing services. So, for example, parcels of melee could be sent in, screened, and then sealed with the specific results of what those the screening results are. So, really, really nice that you've got options there. Sometimes one measurement alone is not enough, and even in our area where we've got all the instruments here. It's sometimes we need to take, do 1, 2, 3 different tests to get that definitive answer on what the stone is. And it usually turns out it's just a really interesting, unique natural diamond. so they're the ones that we like to spend a bit more time looking at. Important to know your supply chain pipeline and eliminate any risks, so both internally and externally. So there's always a risk whenever anything leaves your facility. So if there's loose leaving a facility to go to jewelry manufacture, important that when that comes back, that it's maybe screened again. And then just the last point on this slide is really talking about the Natural Diamond Council's Assure program. So we're now in the 2nd round of testing for the Assure program, but this program was set up essentially to do independent testing of verification instruments. We would find quite often that when we were out and about at trade shows talking about our instruments, people would be asking us what we thought of this instrument or that instrument. And it really depends. And it's sometimes it didn't seem right for us to comment anyway. So it's really nice that the Natural Diamond Council have set up this program where they'll independently test the instruments, and manufacturers can submit their instrument for a fee. They will be tested using an independent sample set, which has been put together intentionally to be quite tricky. It's quite a tricky sample set. So it's testing all of the instruments for various metrics, whether it's speed, diamond accuracy, natural diamond referral rate, all that sort of thing. And then the results are published on the Natural Diamond Council's website under the Assure program. So potential customers can go to that website, read up about the instruments, get a bit more information about that, and then ask the relevant questions when they're then talking to the manufacturers. So I think that works really nicely now that there is that independent voice out there as well. So that's the instruments. So I think now Nick will go through some of the processes and how we see the instruments being used in a screening methodology.
Okay, thanks, Sam. Yeah, so what I'd like to do is just to walk you through, as Sam said, some screening methodologies and sort of case studies. So the next few slides show you how we would envisage that the instruments are used, either on their own or in tandem. So firstly, if we look at melee, so if we're looking at, say, AMS2, we're looking at a third of a point up to 20 points, and similar for synthetect. So taking AMS2, what you would do, you would take your parcel of melee diamonds, and you can simply tip those into the hopper. And then what would happen is those samples would then automatically be tested by the AMS2 instrument. And then, as Sam showed, they'd be dispensed into a number of bins: pass, refer, synthetic, and one diamond, depending on what the machine tested them at. The synthetects can be used where you have a tray, so you can put your melee stones onto that tray and push that into the synthetect instrument. And then you're really looking at the color. So you're looking at this phosphorescence. You want to see this blue color for a natural diamond. And you can use the software tool that Sam showed just to click on those stones just to confirm that they're natural. So there are two ways. If you want to screen automatically, leave that instrument running. AMS2 is a great tool for that. What you do need to do is make sure that the size is consistent. So you can't have mixed sizes, so you have to put the same size stones in. What you'll find is, obviously, the refer bin would need to be tested in a bit more detail. How would you do that? Where would you go? If the samples were large enough, you could test those on Diamond View Zoom, and that would tell you if you have natural or synthetic. If they're a bit too small for Diamond View, or you haven't got Diamond View, then you could use a gemological lab to send those stones to and get those refers tested. So that's loose melee. If you were looking at larger loose stones, so 5 points, say, and upwards, then first stop would be a screening instrument. And our first line screening instrument, as Sam mentioned, is Diamond Sure. So Diamond Sure will screen from 5 points up to 10 carats, and pretty simple to use in that you would take your loose diamond, put it on the tray here, push the button, and hopefully you'd have a pass. So the route through would be testing your loose stones, then having them mounted in jewelry, and then onto retail. There is the potential that you've either got a synthetic diamond or you've got a natural diamond that has to be looked at in more detail. So what you'll find is you may have a stone that refers. That stone can be tested on Diamond View. So Diamond View can then be used to basically detect if that stone is natural or synthetic. Hopefully that stone's natural, and that's passed, and it can then be mounted in jewelry. So talking of jewelry, so the synthetect was designed primarily to look at stones that have been mounted in jewelry. So it's a challenge. Not all jewelry pieces are the same. Some can be very intricate. So what we have endeavored to do with synthetect is try and build a number of attachments that allow you to get access to looking at those diamonds mounted in jewelry. And then basically using the same process as you would for loose stones. So what you can do is you can take your bangle or your ring, and then you can switch on the ultraviolet light that will induce this blue phosphorescence if you have a natural stone. And then you can simply use the software to click on that stone, and it will give you an answer, natural or refer. So as we've mentioned throughout this, there are some natural stones that may give a refer result and need to be tested in a little bit more detail. This can be done at a gem lab. The real issue, I suppose, with screening and looking at diamonds within jewelry is the fact that if you want to look at those diamonds in more detail, then you're going to have to demount them. So the process of using AMS2 to screen your loose melee diamonds or your loose polished diamonds, and then having the jewelry manufactured, and then as a sort of a check that your pipeline is secure, you can then use the same technology. So that should eradicate any spurious results there, but it will obviously catch anything that's been switched in the process, any synthetics that have been put in unknown to you. So the standard Synthetect will allow you to screen quite a few jewelry pieces, bangles, earrings and rings, but if you want to look at larger jewelry pieces, we have what we call an XL base. So the standard Synthetect will then sit on your XL base, and you can put your larger sort of jewelry pieces, your necklaces. You could also put an array of other pieces, so you could put an array of rings in there and quickly screen through those. So it allows you to quickly screen through lots of jewelry pieces, or to screen those diamonds that are in larger jewelry pieces. And again, what you're looking for is this blue characteristic phosphorescence, and you can use the software tool to determine if you've got a natural stone or something that needs to be referred. And again, those referrals can either be, if they're large enough that they have to be demounted, can be looked at on view or sent to a GenMat. So hopefully that's given you a walkthrough of how you might use these DBIs in your process and where they fit into your pipeline. As both Sam and I have said, there's ongoing research and development on these instruments. So we're currently looking at a new instrument, AMS Micro. So this is taking the size range down, so it's going from 1/3 of a point to 1/10 of a point. And we're also looking at, say, a retail level screening solution as well, which we are always welcoming feedback on that. You can imagine that no two jewelry pieces are really the same. You have some quite intricate settings, and getting access and a direct line of sight to those diamonds is quite difficult. So any suggestions or any advice or feedback on what we can do and how we can make that easier is always welcome. And in particular, I guess the retail instrument would be of interest. I wouldn't necessarily propose that as a selling tool for a consumer, but it would allow you, if you're buying from external vendors, if you're appraising, if you're having repairs or buybacks, it allows you to make sure that the stones that are in those pieces are natural and not synthetic. Also, I mean, obviously the consumer is very well educated and may come into your store and say, how do I know this is a natural diamond? And if you have knowledge of the diamond verification instruments and also have used them, you can answer that question. So just like to conclude with some key messages. So all synthetic diamonds are detectable. You've seen that, yes, it can be difficult with the loop and tweezers, but you just need the right technology to identify natural diamond from synthetic diamond. Davies provides those diamond verification instruments, both for loose and stones that are mounted in jewelry. And you can see that the instruments and the processes are backed by an industry-leading research. You know, we've got a lot of resources here that we can look at diamonds, investigate diamonds, and we treat that as a continuous process. You know, we are continually challenging our instruments and making sure that not only are they robust now, they're robust into the future. And really, the last 2 points are calls to action, I suppose. So you have awareness of current issues, making sure that you're aware of current issues in the industry. I've certainly seen in the last couple of weeks where there are reports of very large synthetic diamonds with natural diamond certificates, so fake certificates. So that's making sure that you keep up to date with what's happening. The development of melee screening was really to address some of the issues that we saw in the trade with natural diamond melee being replaced with synthetic diamonds. And then the last call to action is ongoing education. So education of yourselves, your staff, any retail staff. So then when the consumer does ask you the questions, you're able to answer those in a confident way. And really just in general, just to be educated in the current issues of diamond screening. So with that, I'll say on behalf of Sam and I, thank you very much for listening. We really do appreciate your time. We're going to take some questions. Whilst we do, I'm just going to leave this page up. So you've got 2 QR codes. The Ignite verification instruments will take a link to that site, and also education services. So I've mentioned education. So the Institute of Diamonds education services, you can access that through the QR code. And yes, thank you for your time.
Perfect. Thank you so much, Nick and Samantha, for the presentation. So as mentioned, to our attendees, if you have any questions, please post them in the Q&A forum. In the meantime, we do have a few here that have already been submitted, so we'll start with those. So the first question we have here is, what SW wavelength is being used for the most recent Diamond View and SynDetect? Also, are there plans to incorporate other UV wavelengths, such as a tunable UV light source?
Shall I take that one, Sam?
Yeah, go on. It sounds like somebody that we need working in our development team if they're coming up with ideas.
Yes, it does. So the wavelength is around about 220, 225 nanometers, so very short wave UV. We currently are looking at a range of excitation sources that's probably going to take place in the next generation of instruments that we look at. But we find that shortwave UV illumination is very effective.
It actually excites fluorescence in all diamonds. So even if you're thinking of a diamond, if you're grading for fluorescence, that's usually long wave, and you might have, various intensities of fluorescence there, and some showing almost negligible. If you're using this short wave, because it's at that wavelength, it excites surface fluorescence as well in all diamonds. It means that we can always look at that color of fluorescence, look at the phosphorescence, look at the pattern. So it's really useful to use that for us.
Okay, thank you. So the next one we have here is, why do synthetic diamonds fluorescence differently than natural diamonds? Why more intense under SW than LW?
Shall I go first, and then if you can add anything I've missed, Sam? So in terms of I talked about the growth environment and the growth conditions being different from natural and synthetic. So what goes hand in hand with that difference in environment is the impurities. So when I talk about impurities, it seems unfair to talk about impurities in a diamond. These are what we would say atomic impurities, and they're just small elements. And there may be nitrogen, maybe silicon, something like that that's incorporated during the growth. And you can imagine that when your stone is grown within the earth, there are lots of different elements available that might just kind of incorporate themselves into that diamond lattice. And then when you look at growth within, say, CVD reactors or HVHT, the environment's different. There might be some contamination from nitrogen, which is very difficult to drive out. There might be some ingredients that are very key to the chemistry and the growth. And what happens is, when you illuminate with UV, you're looking at fluorescence from not only the intrinsic diamond, but you're also seeing the effect of having those very, very small amounts of atomic defects, kind of pp, parts per billion and parts per million, small atomic defects replacing the carbon. And that gives rise to the different colors that you'd see in fluorescence.
This is another question about, we have another question about the wavelengths used in the SynDetect. And did you say naturals do phosphorescence at this excitation?
Yeah, so it's the same excitation that Nick's already talked about. We're talking, because it's because we're looking at, I think when we think of phosphorescence, we think of that very long-lived phosphorescence. So you switch off a UV source, and is there any fluorescence, any afterglow that we can physically see, you know, in a darkened room if you're looking at diamonds? What the synth detect is doing is taking phosphorescence in a very, very short time window and grabbing an image very quickly as it's decaying. So the phosphorescence that you see in the natural diamonds is different to what you see in the HPHT synthetic stones, where you see that very bright turquoise, long-lived phosphorescence. So there is some phosphorescence, but normally by eye in natural diamonds, it decays away so quickly that you don't see it. But yeah, it is there.
Okay. Next, I see that diamonds are your primary focus. Do you expect to expand into identification of other gemstones in the future?
Not that I know of. And diamonds are tricky enough, so we'll stick with diamonds. That's Davies' core business. We'll stick with that.
Davies is all about the diamonds, isn't it?
Although other gemstones are amazing. I mean, some of the colours and things, it's yeah, obviously very interesting. So I think we've looked at sort of in the background at various other options, you know, maybe from not in a polished state, but some sort of identity. If you think of you using sort of identification tools, spectroscopy for identifying materials anyway, and a lot of the instruments that we've been using, infrared, UV visible spectroscopy, you would use that to analyze any material. So you could do, but our expertise is in diamonds. Our knowledge is there. So I think we'll stick with that.
Fair enough.
Not for me anyway.
What about diamonds that have been laser treated for imperfections? I know that can change results on certain testers.
Yeah, so those treatments, I hope I'm right, Sam, they don't affect the measurement that we're making. I think they're more clarity enhancing treatments, and we shouldn't see any, we might see the actual tracks, we might see the effect in diamond view, but it shouldn't change the performance of the instrument.
I think maybe are they asking, does it affect a measurement in some of the, I guess if you've got a really included diamond that's maybe had some laser drilling, but it's still pretty included, that might affect some measurements on some instruments. If you've got lots of dark inclusions and it's absorbing a lot of the light or something, yeah, I don't know. I'm not sure which instrument particularly they're talking about, but I think for ours, it doesn't really affect it.
Can synthetic diamonds be assembled with natural diamond crown or pavilion?
Yes, that is possible. It's something that's a big risk in that growing on natural diamond, you would I guess you would use the CVD process, and then growing on natural diamond is pretty risky. It's difficult to get the right match between the natural and synthetic, causes a lot of stress. So you're risking your natural diamond putting in a reactor and growing on top of that. So in theory, yes, it's possible. I would say if it's quite a risky process, and you may end up with destroying your sample that you're maybe growing on top of.
How common is phosphorescence and fluorescence in natural and synthetic diamonds? I'm trying to ask how reliable is an SW or LW lamp test for HTHP diamonds?
So I think in general, if you're using a standard, we say that a standard UV sort of gemological lamp can be useful. What's really important is to make sure that it's fairly new and not an older version, because the lamps do degrade over time. So it's good for HPHT synthetic stones because they will phosphoresce really, really strongly. They'll be really obvious to see. The trouble with CVD synthetic stones is that they don't phosphoresce. So they might show an orange fluorescence. So you might see an orangey colour in the as-grown material, but then if that's been treated, it might affect that. So it might help you certainly before a lot of the automated melee screening devices were around, we said that would help to a certain extent if you had a parcel of melee and you just wanted to check whether there were any HPHT synthetics, and that might help in that respect. But I think just using that, you would miss a lot of synthetic stones.
Does De Beers anticipate the value of synthetic diamonds to go down as more retailers use detection tools?
That's an interesting question, in that I think we're already seeing that the price of synthetic diamond is going down. And obviously, if the detection tools are out there, then you can confirm if you've got natural or synthetic. I think what's really interesting about that is that as the price of synthetic diamond goes down, maybe there's more of an incentive. And I suppose we've seen that in the industry now. We're looking at those synthetic diamonds which have fake and natural certificates. So I think now is an important time, in that because the price of synthetic diamonds is coming down, it's more important to be able to identify them, because people might start to try and pass them off as naturals to try and recoup some value from them.
Can diamond-coated simulants test as natural in these instruments?
No, I think they would. I'm always intrigued by these diamond-coated simulants, because we've done quite a few studies on, we purchased material and looked at them, and a lot of the time we can't actually see any, it's almost like a diamond-like carbon coating on them. It's not actually diamond coatings on the simulant. So what we would find in our instruments, they would refer, so they wouldn't pass. They just won't show the fluorescence and phosphorescence behaviours of the natural stones that we would expect. So.
How much market share have CVD taken from natural diamonds?
That's another good question. I think what's important to think about is that when you talk about market share, it's really the synthetic diamonds can address kind of particular sectors of the market. So it's not like they're taking market share across the board. It's maybe those larger stones. So that's important. So it's hard to really say what the percentage is, because you have discrete areas where maybe synthetic diamond is taking a little bit of market share, but you have to be careful when you look at the overall size range that you might find.
I think it's worth noting that, you know, the sales have definitely gone up, but I think we're also at this quite an important crossroads as the price of lab grown does come down quite considerably, and you know, consumers that purchased lab grown jewelry pieces a year ago are now holding something that's worth a lot less than it was then. So, and I think that consumers will be asking retailers a lot more questions about, you know, what they're worth, the actual value of that product. So if the prices just keep coming down, it's going to be interesting to see how that pans out. So.
Okay. We handle jewelry that is bought from clients or estate sales, so we see everything from antique to modern. I don't think I see one system that would work for us alone. For example, taking out or unmounting individual referred stones for further testing isn't cost effective. Do you have any advice as to which testing system would work best for our business?
Yeah, it's tricky, and it's always the thing that crops up. I mean, the last thing anybody wants to do is start, you know, demounting stones from a jewelry piece. So it's really we try and sometimes there isn't one answer. Sometimes it is that screening before and after. I mean, antique pieces is going to be a very difficult situation. So yeah, very tricky. And I mean, that's why we really are focused this year on trying to develop some of our instruments or look at the next generation that can do more with set jewelry pieces, because that's the last thing we want to do is unmount. So yeah, Nick, I don't know if you've got anything else to add to that.
Yeah, no, I mean, Yeah, you're right. And I think something to highlight really is what we try to do with our instruments. And I think Synth Detect and AMS2 was certainly an important step forward, because we were looking at referral rates. So you want to minimize referral rates. Nobody wants to demount stones, etc. So we want to make sure that we reduce that referral rate as much as possible. So we've endeavored to do that. So if you were to look at the Assure program results and compare instruments, that's an important thing. That's an important parameter to look at, is what's your natural diamond referral rate, because that's going to obviously impact on whether or not you might have to demount stones. So yes, it's tricky, and I think Synth Detect is the kind of instrument that you'd use. And just to say that we do appreciate that nobody wants to demount stones, and that's why our research is focused at trying to minimise the referral rate that you get from our instrument.
It's almost a bigger thing as well, isn't it? Because it's about relationships that you've got with other parts of the business. It's about documentation that goes hand in hand as well. So it is a combination of these things that need to work, and it just shows that the industry as a whole needs to work together on this. Nobody's got the one answer for everything. So that's why we're out doing some of these presentations sometimes, because it's really nice. Some of these questions are really, really interesting, really tricky as well. It's good to get tricky questions because it gets everybody thinking about it.
Definitely. So I think that's about all the time that we unfortunately have for questions this afternoon. However, the contact information is up there for anyone who needs it, to anything that we didn't capture, or if you think of any questions that Nick and Samantha can answer via email later, we'll make sure that gets taken care of. So once again, I just want to say thank you to Nick and Samantha, as well as the De Beers Institute of Diamonds, for a great presentation. A recording of the complete webinar will be available on the webinar section of jewelrybusiness.com 1 week from now. We'll also be sending a link of the recording via email to all of today's attendees. So thank you to everyone who joined us for the presentation. And before you go, please take a few minutes to give us your feedback by completing our survey. It should appear in your browser after you close the webinar. Thanks again, and I hope you all have a great afternoon.
Thanks all.
Thanks for your time.
Bye.